Heard AM, you've heard FM. Now, tune into DM Radio, the world's longest running show about data. Each week, host Eric Kavanaugh interviews the brightest minds in the world of information management. Want to be on the show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanaugh.
Gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly here, Eric Kavanaugh. Wonderful all-star lineup for us today, folks. We're going to talk all about machine learning, understanding ML's growing role. Machine learning, of course, refers to this wonderful technology. I'm getting an echo here, so hold on one second. All right, machine learning. There we go. Machine learning refers to a set of technologies that learn over time, that are able to optimize all kinds of things, from pricing, for example, to processes, business processes. There are so many different ways that you can optimize business. And it turns out that we humans are fairly predictable. So the stuff we do, once the machine scans it and follows it and kind of understands where we're going, machines can be very good at knowing what we're going to do next. So that's why machine learning is such a powerful technology these days. And of course, it needs data, right? You have to train these algorithms to be able to do clever things. And in order to do that, you need some sort of platform. But even there, the technologies are getting better in terms of making it more business friendly, low code to no code environments, for example, or low code to pro code, as some people refer to it. So the technologies used to deploy these types of algorithms are getting much better. And then, of course, you look at the big guys, Facebook, LinkedIn, Instagram. I promise you, these folks are using machine learning in all kinds of ways, whether it's to optimize the flow of traffic on their sites, whether it is to optimize the algorithm of what content you see. And of course, they want you to stick around, right? That's what they use these for primarily, is to understand what you want as a consumer of information and how they can better serve you and keep you rocking and rolling. So today we're going to talk to several guests. We have Ryan Rees, Ben Fan, and Josh Rubin. And I guess I'll start over with Ryan. I'll bring you in. Ryan, tell us a bit about yourself and your company and how you were helping organizations leverage machine learning.
Absolutely. Thanks, Eric. So I work for a company called Mission Cloud. We are an AWS Premier Partner, and we are a full service integrator, and we work with companies, wherever they are on their journey. My particular team, I run the data analytics and machine learning team, and we help customers wherever they are on that data stack, right? Whether they're just starting out trying to get into the cloud onto AWS and do reporting, or whether they're working in more advanced analytics, starting to do machine learning, or maybe they are already pretty advanced doing machine learning. And one of the things we see, and it's often hard to believe, is that people have built tons of models. They have data scientists on staff, and they never get those models into production, right? I've walked into companies that will have 10 models just sitting on the shelf, and they're wondering, how do we get these models into production to help our business? So we help them, move those models from, on-premise into AWS. And then what people often, that aren't in the field don't realize is that, hey, a model is kind of like a living organism, right? It's got a lifetime. Depending upon what kind of data you use to train that model will then tell you how frequently you need to retrain. If you think about real estate, it was going along pretty good, and then COVID hit, and everything changed, right, in the world of real estate. So if you were tracking your models and you never updated it once COVID hit, then your models would be greatly wrong as you're sitting there trying to make investments or other insights on what's going on in real estate. So that just kind of shows you one example of how data changes and then drives you to make sure to retrain your data. A lot of companies are retraining every day because their data is changing so frequently. So with that, you really have to start thinking about an ML ops, which is equivalent to kind of the CI/CD pipeline and DevOps and then doing cloud native development, where people no longer are looking at the, hey, let me release an update every 6 months, right? It's now we're releasing updates daily or hourly. You're just able to push out new products all the time, and so the same thing in ML, pushing out new models as frequently as you need it to keep that accuracy and performance that you're looking for.
Yeah, that's a really good example too. And COVID threw off quite a few machine learning algorithms from my understanding because human behavior changed dramatically. I mean, the psyche changed, the behaviors, where you go, when you go places, all that changed. So that was a real, what's the expression, come to Jesus moment, I guess, for the industry, right? Because a lot of companies realized they had to throw out all these different models for predictive capabilities, whether it was for next best offer or pricing or whatever, because the whole world changed and they had to go and like retrain all the algorithms, right?
Absolutely. And so if you didn't have that MLOps auto training, then, like you said, you had to hope that the person that trained your model was still on staff because people move around. And so,
Right,
hope
that's
that
right.
tribal knowledge is still there so that you can train. And you every time you retrain, there's always something new that pops up, right? Some new edge case that you sit there and investigate and try to understand. Hey, what's this edge case telling me? Is it truly something I need to worry about, or is it just some noise that's not really going to happen? So retraining is always an adventure.
Yeah, and since you know a lot about this, explain to our audience overfitting the model, right? This is always a danger with machine learning, to overfit a model where it's just kind of telling you what you want to hear instead of telling you what's really happening and giving you ideas about what to do about it. How does that happen from your experience, and how do you avoid that?
So there's a lot of interesting things that can happen when you're training data. I think overfitting, is obviously one of the big ones that people talk about, where you often will see somebody will take a data set and they will put in, huge numbers of samples, train the data on that, and then it kind of gives you an impression of, hey, your data looks like this, and then some new data comes in and it doesn't fit on that model. It's not necessarily an edge case, but it's a case that you didn't put into your data set. And so now it seems like it's that your model's not working. And one of the things that we talk about a lot with customers is the importance of creating a good representative data set, right? A lot of people don't put a lot of effort on creating their data set. They just grab a bunch of data, right? They'll just let me grab, all the data I have right here for a particular use case and train against it. And, often, they'll have millions of points and train it, and you'll see kind of that overfitting. And often it happens where you put more and more parameters in, right? Where you might have a model, sometimes you'll see somebody build a model with like 50 parameters. And so that's one of those other cases where you start getting overfitting, where you're trying, you can kind of think about it as, hey, I've got a line, like a saw line or something like that, and I put in a huge number of parameters to get all of those little triangles in there, when an average might be better fitted at the end of the day. And so that's part of that overfitting, is just you're trying to tweak it so much to get 100% accuracy that you often just lose details that you need for predicting.
That's interesting. That's a good point. And before we bring in our next guest, one last question I'll throw at you, which I also find very interesting, which is this process of kind of introducing some noise intentionally, or some people refer to it as kicking the models a little bit. What can you say about that, about trying to kind of like throw the model some data that's going to change things a little bit, almost like you used to hit the side of your TV back in the old days? What do you think about that?
I think that's, it depends on the type of model you're trying to do, right? And some people are doing that more on kind of your deep learning models, because they're oftentimes black boxes, and no one quite understands how the black box works, right? And if you made a predictive model, people are already trying to take into account those differences you would have by constructing your data set and then doing things like, 7 folds. That's where you break up your data set into a bunch of different pieces and then fit each of the pieces, and then come back and look at, hey, how's my model look across all of these different pieces as you fit it, right? There's a lot of traditional techniques that aren't necessarily used in deep learning to try to get past some of those endpoints. So what they're really trying to do is they're worried they're hitting a local minimum, not the global minimum, because basically all these are optimization functions. And so, if you're in a local minimum, they try to hit it to pop it out of that to find the true global minimum. And so that's just what they're trying to do on the deep learning side.
Cool stuff. And we'll get into deep learning later in the show. And that's actually a good segue now to bring in our next guest. We've got Josh Rubin on the line. Josh, tell us a bit about yourself and what you're doing in the world of machine learning. Oh, you're on mute. You got to unmute.
Gosh, you would think after the pandemic,
all right.
we would all learn not to do that, but
it's even in movies.
Still struggling, right?
It's even in movies.
Yeah.
Go ahead.
Well, thanks, Eric. So I'm with Fiddler AI. Fiddler is about 4 years old, and I've been with the company for 3 of those years. And our motto is to build trust into AI. So Fiddler provides a platform for enterprises to use machine learning responsibly for a variety of things. And maybe like to start with, I'll just take a step back and kind of, I think Ryan and I will have a whole lot of overlap and a whole lot of commonality in the things that we're interested in and concerned by. So, one thing that we see is just how ubiquitous machine learning is across all business functions. So, I think in some ways the risks are increasing, right? So we deal with companies, we have customers who are in all different segments of industry, right? We have financial services customers, we have e-commerce customers, ad tech customers, personal digital assistant customers who are using machine learning to, infer the intent behind the thing you are asking your digital assistant to do. All of those functions are based on models that are trained to data. Some of those are sort of high risk functions. If you're, going to be, for example, a credit underwriting model in a bank is, a potentially risky scenario for a bank. They're making a decision about how responsibly someone can manage debt.
Right.
Or it could be something totally innocuous like email classification, some internal function in a company that just adds a little bit of efficiency to people's workflows. Call center chatbot classification, that might be kind of a low risk model, but companies are finding all sorts of places to sort of pepper in machine learning to increase their efficiency and also to do new things that weren't possible before. And then I would say kind of a second source of risk is that these models are getting more complex. Mm-hmm. So we certainly see lots of models that are simple regressions, simple like fits to points, like you might do in Excel or in a math class. But increasingly we're seeing things like deep learning models used for some essential functions, and they can really outperform, from a pure utility point of view, from a sort of like measured revenue point of view, some of these simpler models. So an example is, we see a lot of financial services companies starting to toy with the idea of using a deep learning models that can look at a whole credit history rather than just make a simple assessment based on a credit score. But with more complex models, there are greater risks, right? You're dealing with something that is harder to definitively say will make the right decision in every scenario. I would say the third risk is that, as we talked about with COVID, the world is a changing place. And it doesn't need to be a dramatic shift like suddenly a pandemic. I mean, there's things like seasonality in data sets or political cycles or, changing preferences of, consumers in a forecasting model. So all of those things introduce risks in the operation of machine learning in production. Mm-hmm. And we try to provide a stack of tools, explainability, model monitoring, fairness bias assessment that can help companies navigate those risks.
Yeah. And of course, a lot of times it's funny, I'll see news stories where they're blaming the algorithm for being bad. I'm thinking the algorithm is not, it's an algorithm. It's not a person. It can't be a bad algorithm. It can be a poorly functioning algorithm or a poorly designed algorithm. But don't blame the algorithm. Blame either the data or the person who designed the algorithm, right?
Totally. Yeah. And to connect up with Ryan's comment about ML ops, I mean, that's a big term for us. So our stakeholders are, data scientists, model developers, people in this ML ops role of actually running a model in production and making sure it's doing the right thing. We think of ourselves as a model performance management platform. And that basically there is a sort of responsible AI practice that basically model development doesn't just end when the model is rolled into production, but that, part of responsibly using AI in a production setting is instrumenting it with, things that can show how it's performing over time, how its
Right.
inputs and outputs may be changing with time, providing diagnostic tools for asking questions about why it made a decision when it made a bad decision, tools
Right.
for segmenting analysis so that you can see that, the model is making decisions on the right features and not some, unfortunate, not parroting back some unfortunate sort of demographic injustices that it's learned from spurious
Right.
correlations.
Right. Well, it's like you have to be very careful. And this, I think, is a red flag for organizations. When you decide to deploy machine learning or artificial intelligence, you need to be very careful about which data sets you point it at, because that's the data where it's going to grab the information it uses to make its calculations, right? So if you point it at old data, stale data, bad data, inaccurate data, you're going to get a very unpleasant response on the other end, right?
Absolutely. I mean, there's lots of ways that this can go wrong, right? If you could grab a data set that's too narrow in time, you might not capture totally natural seasonality in your data. I mean, you can imagine, usage of, a cell phone network goes up and down during the day, depending on when people in that area are awake and asleep.
Right.
And if you are monitoring your data on a baseline that's too narrow, if you're comparing it against or training a model on a time window that's too narrow, a totally natural cycle in your data set may look like wildly unpredictable behavior when you chart that on a graph. And so there's some pretty careful considerations that go into that. And I would also throw out there that, we all know this old adage that correlation isn't causation, right?
Right.
And a lot of the dominant techniques for doing machine learning right now don't have any sort of intrinsic causal model that they're trying to build, right? So they're inferring something causal from a pile of data that we've given them. And so, without some care and without some diagnostic tools that give you the ability to sort of ask the model why it made its decision, it could totally be learning inappropriate causal relationships between variables that are correlated. I mean, when you think about, historical, sexism, racism, things that, it's just such a simple peril to run into is to reiterate those because a model has learned something causal from something that was an unfortunate statistical correlation.
That's a very, very good point. And we'll get deeper into the deep learning, no pun intended, in our upcoming segments. But one of the challenges is that in some of these deep learning models, you have hidden layers. And, what's interesting is that there is a certain proprietary nature to the algorithms that are being run by Facebook and Google and other companies where they don't want to reveal the recipe. But I think there's going to be a bit of a challenge on that front sooner or later. At least I hope there is, because I'm a big fan of transparency, and besides which, execution is what matters in business today. But don't touch that dial, folks. We'll be right back. You are listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
On DM Radio, we're talking all things machine learning on today's show, ML's growing role in the world. And of course, it's under the covers all over the place, folks. Machine learning is being used by lots of different large corporations and quite a few startups and small organizations as well. And it's really good at optimizing processes. Of course, it's used quite a bit in segmentation, trying to figure out which group do I put these objects in, or these people, or these products that people want to purchase. That's one thing it does. It also optimizes for pricing. But as we discussed in the last segment, sometimes you got to be careful about what the decisions are that come out of these machines. And explainability is a big part of machine learning, and especially AI these days, especially with deep learning. So a man who knows a thing or two about that is my friend Bin Fan from Alluxio. So Bin, welcome back to DM Radio. Tell us a bit about what you've been working on and how it's going.
Thanks, Eric. I'm happy to be back. And I'm Bin Fan from Alluxio. I'm one of the founding engineers in Alluxio, and right now I'm running the open source initiative in Alluxio. So we are a open source technology vendor focusing on data, focusing on how to present the data closer to applications. So applications like machine learning training frameworks or training jobs, they can access the data more fast with higher bandwidth, faster, and also cheaper. So that's basically what we are doing. Different from Ryan and George, they're more from the model side. We're more from like, hey, if we want to build this model, how do we build this model more efficiently using less resource or using cheaper price, reduce the cost. That's basically the starting point we are, how we are talking to our users. So essentially, like the data challenges we see, there are different, like machine learning, the full stack, right? There are different challenges in explainability, in monitoring, in ML ops, all different things. Like the angle we're entering here is more from the efficiency perspective, especially for the IO efficiency. And interesting enough, like we are a software, or we are we are a open source project, starting from more like from the data analytics side. This is originally a research project incubated from UC Berkeley AMP lab as a sister project for Apache Spark, how to present Spark data more fast, or helping Spark. But interestingly, like we see there's a difference where people naturally think, hey, you can help me solve this data analytics problem. How can you help me solving this machine learning problem? And we notice there's a difference here. Like what we are doing for the data analytics for Spark, for Trino, for Presto, is not necessarily translated to how machine learning the users and applications are using data. Like I'm just giving you a few examples. One is the data set is very different. For machine learning, from time to time, we see users or applications are using a big pile of small files, typically video clips or pictures, and they are typically on the order of a few hundred megabytes. Few hundred kilobytes. Megabytes will be awesome for us, but on the few hundred kilobytes to represent a picture or something very small. But that's just super common for machine learning applications, and that is not how the conventional, I would say, like a previous generation of a big data platform is designed for. So we need to do something very different. And also, like for example, the API is very different in the data analytics world. By default, people will think, yeah, we can use Hadoop file system API or client to access data, but which is not the case in the machine learning world. And also, we found it's also because the latest advance of all the hardware, like GPUs, all this type of specialized hardware, machine learning jobs can run in a highly parallel way. They're very good at leveraging hundreds or thousands of different threads are doing their jobs in a parallel. And that makes the application super efficient, but also creates a lot of challenges on the IO side. How do you feed them? How do you feed these applications to keep them less hungry? Or because GPU instances are typically the more expensive instances in the cloud, right? So you want to you want to reduce your costs. You don't want them to be idle because they are waiting for some data to be fed. Yeah. So these are the challenges we're seeing from the lower level, not rather from the model side, but from a lower level, how we are helping data scientists or machine learning engineers to feed their pipelines in an efficient way. Yeah, so these are the interesting and also very challenging problems. We're working on that, and we get a lot of people, it's open source project, so we get a lot of people working together with us globally, and we're making a lot of progress.
Yeah, that you pick up some really, really good points here, because cost is always a concern, right? And when you get into training some of these models and leveraging these models, to your point, if the training is not an efficient process, it can be rather expensive, and especially expensive if it doesn't do what you wanted it to do in the first place anyway. So you want to be able to train the models and engage the efficacy of the models. And then, one of the challenges really has been going from your notebook, your Jupyter notebook, where you're working on stuff, to production, depending upon the environment, because a lot of these large organizations have lots of legacy systems that weren't really designed for that kind of input. So you have to come up with some framework, some mechanism by which you insert the analysis or you insert the intelligence into the operational system. And then you have these challenger models too. Like theoretically, you should have your production model and you should have a couple challenger models kind of waiting in the wings, ready to move over. How far have we come in terms of being able to quickly replace models that are running? And that's, of course, the ML ops stuff that I guess Ryan and Josh were talking about, right? How far along are we in that front?
I guess this is a question for Ryan.
Yeah, that's a question for you. No, it's for you too.
Oh, it's for me too. Okay,
yeah, go ahead.
Yeah, so we are talking with quite a few users. They're seeing these challenges, and they are saying, "Hey, how can you help us to make sure this is all the data is all the model is quick? We can quickly update it, all these things." And the situation is it really depends. It depends on different applications and depends on the data platform. And we're seeing a lot of users. They are not only just like for example, creating their own they have their own different challenges, and especially for our users, from time to time they have this, for example, data silos, or they have some different management problem to prevent them to get this down or deployed really easily. So that's the one direction we're helping them. But I would say it's a still very early stage in general. The entire machine learning world is it's super hot and everyone is talking about it, but still the tech stack is still quickly evolving. Yeah. There's a lot of different moving pieces, and there's a lot of I would say also legacy pieces there. So and we're seeing very different pictures from one company to another company. So I would say that's where we are. We're trying to, at least we are trying to help people from one angle, and we're just saying it's still very early of the game.
Yeah, you brought up another really good point here, which is that the tech stack is changing. So it's a good segue to our roundtable. I'll throw this first to you, Ben, and then to the rest of the panel. Yeah. Because if you look at, let's talk about data science platforms, right? There are a number of really cool vendors out there that have data science platforms. We were talking about that this morning on a call, in fact. But they really need a team. You need a data scientist, you need a bunch of engineers, data engineers. And of course, those people are in tremendously high demand right now because there's just not that many of them. And there's this tremendous need that's growing. Then on the other side, you have low code, no code platforms, which are slowly rising and getting better and better at being able to build nice GUI interfaces on top of the algorithms and all the number crunching underneath. And that's clearly where we want to go. But it seems to me we're probably still kind of far away from that. But that's what the business wants. Like if I'm a business person, I don't want to have to get lost in the mire of understanding R or Python and understanding data pipelines and and observability and how that plays into it. I just want the car to run the way I want it to run, right? So the business people want the easy interfaces. Where are we in that evolution? And what's your advice to an organization that really wants to leverage this kind of technology, but just isn't sure, how much to budget for it? How many people do we need? I mean, these are difficult questions to answer. Ben, first, what's your advice on that? And then we'll go around the room and get the other folks. Go ahead.
Yeah, that's a very good question. So based on my conversations with the users or customers that are running their machine learning pipelines, their machine learning platform. So one advice I typically give them is if you want to build a tech stack, and you want to build this as you want to have a smaller team to maintain. You don't want to have a huge team to maintain. That's going to be very complicated. You want to leverage. You don't reinvent the wheel, definitely, right? You just look for what are the functionalities you need, and look for vendors on the market. But also to make sure your architecture should be future proof, and that is actually very important. Like you don't want to be stuck in some legacy architecture or legacy tech debt, so it's hard preventing you to move for the next day. Because as I mentioned, technology is still evolving quickly, and the models are evolving quickly. Right. These giants are still creating models, very awesome models for the newer applications. You definitely see this trend is that the train is still, I won't say, it's still going very quickly. So you should be prepared. You should leave enough room. Say, hey, we need to maybe revisit the architecture in the next maybe 2 years or something, right? Mm-hmm. So really just to be prepared. Just make sure that this is very, you have enough room to make your tech stack evolving to the next or changing a little bit direction, these type of things.
Yeah, that's a good point. And Ryan, I'll throw over to you. What are your thoughts on that, on how to recommend the right course of action for your clients or people you talk to?
Yeah, some of what you're describing of where's the future, do we end up in a dystopian world, like the Matrix background I have, or the Terminator coming after us? I often think that that's not going to happen because, you look at things like AutoML and you look at everything people are trying to do to make it easy. it just doesn't really work, because you still need to have somebody that's got insight, that looks at the data and understands, hey, this is good data or this is not good data that's going in, right? You still need to have somebody look at the output of a model and say, hey, this is actually makes sense, right? Nowadays with Stack Overflow and everything else, anyone can be an ML engineer. Anyone can go out and get a model to run, right? I'm old, and I remember doing data science, and some of the first papers on what became XGBoost came out of Stanford. And if we wanted to use that, we had to code it all ourselves, right? You had to sit there and code it and understand how to group everything and all that. But nowadays, anybody can go out, grab a library in Python, stick it into their code and run it. But that doesn't make it, a good model. It doesn't make it have something that you're going to be able to talk about and report on. And, we're seeing a lot of that with our customers, where they tried to go out on the cheap and just grab somebody to run them a model and they get results. And, once they really dig into it, it just doesn't work, right? That you still don't have a really good data science base of people that understand it or to build it. And so, people are trying to make all these tech stacks, and I think there's a lot of value in some of them, but a lot of auto ML stuff, still needs a trained data scientist to look at it and make sure, hey, these models make sense. The data I put into it makes sense. And until you improve or figure out how to create something that makes sure you have good data, you're always going to have someone in the loop to make it work.
Yeah, that's a really good point and a good segue to bring in Josh as well, because you're right. The human is never going to go away. The storyline in the media and the mass media, at least consumer media, is, oh, AI and machine learning is going to take away jobs. No, it's not going to take away jobs, or if it does, it's going to take away the really tedious, boring jobs that humans are not good at and really don't want to do anyway. And I think what's going to happen is, the best expression I've heard is that AI won't take away jobs, but people who learn how to use AI will get the jobs, and people who don't won't, basically. So it's a new tool. It's a new platform to leverage in business, and you should figure out one way or another how to do it. Right, Josh?
Yeah, absolutely. I think my best advice is keep it simple as a starting place. There is this incredible tendency in using ML in industry to grab the shiniest thing that you just read about on your Apple News feed or saw on YouTube. And in so many scenarios, there's a much simpler solution than the world's biggest deep learning model to solve the problem that you're trying to do. So I wanted to make sure that I addressed that. And I totally also agree with Ryan's comment on, knowledge and tools, making sure you're equipped with the knowledge and tools to use this technology responsibly. There's a question of how risky a model is, like what is its function? What are the risks involved? I mean, there's a whole school of thought right now that is focused on, what should ship with your machine learning model. I mean, people talking from there, there's been, I think Google had this sort of strong push towards this notion of model cards that, along with your machine learning model, you should provide basically a prescription label for information about what it was trained on and
How interesting.
Make a risk assessment for various kinds of uses of this model so that, whoever receives it can make some sort of intelligent assessment.
That's a really, really good point. And I'm glad you mentioned that, because that's good advice for anyone out there using these technologies, using these models. Have the prescription, explain what the model is supposed to do, what the effect is supposed to be. Don't touch that dial, folks. We'll be right back. You are listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on DM Radio, yours truly, Eric Kavanaugh here. We have several wonderful guests with us today. We've got Ben Fan, of Alluxio, Ryan Reese, and Josh Rubin. And we're talking all about machine learning and how you can use machine learning technologies to optimize your business, to keep your employees happy, quite frankly, because, and I'll throw this out to our guests for comment on each. I think one of the most powerful uses of machine learning and artificial intelligence is going to take the form of suggestions, meaning the AI, the ML is under the cover, it's kind of scanning, looking for stuff, and it's going to give you suggestions of what to do next instead of just taking decisions for you. It's going to give you a recommendation about what to do. I'll throw that first maybe to Ryan Reese. What do you think about the manifestation of AI and ML being suggestive?
I think we're already in that world, to be honest, right? I mean, you look at personalization algorithms, you go to your Netflix, it wants to tell you what to watch, right? You go to Amazon, it tells you what it wants to buy. You know, Amazon's got Alexa, and they've been working on trying to make it more conversational. And if you ask it a question, I think it still works. It was at Valentine's Day, I think this year, where they had set it to really run. You could ask it for suggestions for a date, and it would tell you, given knowing your location, some date ideas that it could have, right? So, you know, we're already living in that world as far as I'm concerned.
Yeah, it's pretty intense. And my daughter, like, I don't like talking to machines, but I'm an old man. And my daughter has no problem talking to machines. She was sitting there talking to Siri, just asking it all kind of weird questions, and it'll even give weird, sassy answers sometimes. Like if she's kind of insulted, like, that's not very nice, which I found a little bit creepy, I have to say. Like one time I was asking Siri to do something and she gave me a completely wacko answer. I'm like, that's just ridiculous. And she's like, that's not very nice. I'm like, all right, is the phone now talking back to me? Like what, like how far are we going to push this model?
There
Right.
was a movie that is out and on Netflix called Jexy, that he got a new phone and it has the latest kind of Siri-like version that tries to take over and control his life and wants to marry him. So, you know, it's not too far in the distant future since the writers are already there.
That's right. That's right. 1984, man, it's coming around the corner. Well, Josh, I'll throw it over to you. Maybe what are your thoughts on kind of where this is all going? And you know, from a business perspective, there's actually a concept I heard a couple of years ago, which I really like. They talk about narrow AI, right? Where it's not the big deep learning red robot that's going to take over the world. It's a very focused algorithm on understanding either classification of signals, like let's say network security or optimization of decision points or whatever. But the key is to keep the focus narrow and understand what you're doing and make sure it does that well. And then maybe you build that into a larger sort of mosaic of analytic recommendations. What do you think about that approach?
Yeah, I would say, you know, from what I see working with customers, and I have to say one of the fun things about, you know, my role at Fiddler is that we're introduced to new customers and new potential customers all the time. And you get on the call with somebody who has some totally new use case. Yeah. And you realize, you know, to go back to personalization for a second, I mean, you just suddenly realize to the degree to which, you know, the order of items that you see in e-commerce to the articles you see on any sort of search, that's all tailored to you.
But is it tailored to you? We once wrote a personalization algorithm for a company that was somewhat tailored to you, but also the first results were what were most beneficial to that company for you to click on, right? So,
well, I mean, tailored to you, you know, you're optimizing for something. And the company is always optimizing for you to click and purchase the thing closest to where your mouse pointer is. So, you know, it's a little unclear who the real stakeholders are here. Well, it is clear.
Well, and that's actually a good point too. And maybe Ben, I'll throw this over to you to kind of chew on. You know, if you look at GDPR, General Data Protection Regulation, this whole concept of right to be forgotten, which I think is a very ambitious goal that they have, right? I think it's basically not going to happen, but you can get close to it. You can strive towards it, I think. And I'm pretty sure that's what the regulators will want, is to see that you're actually trying to solve for that problem, even if it's impossible to track down every last bit of data about you. It's still a bit of a challenge. But then I kind of expounded upon that, and now I talk about the right to be respected. And it basically is just an obvious thing that I would expect you, XYZ Corporation, to be respectful of me, of my time, of my purchasing habits, et cetera. And so if you have that respect baked into your corporate culture, I think you're going to do pretty well leveraging these technologies, because you'll have conversations. And I think the reason we're having so many conversations around ethics with AI is because we are at this very significant inflection point where things really are changing in some fundamental ways. But, you know, what do you think about that whole sort of bailiwick of issues I just threw at you?
Yeah, so previously, before I joined Luxio, I was working in Google, and one of my project is really just making sure the implementing the you get the right to forget, basically your search results,
Right.
your search history, your ads click history, all this, like they can be like you have the option to click, you nuke all this history and make sure like this entire your footprint is forgotten from Google's internal perspective. That's my problem. That's my own project, like in Google. And that particular project, I was I left Google after 2 years working on that, but like I know it was getting very, very well adopted as an upstream for many other downstream applications. Because there's a lot of machine learning models based on different people's history, right? So there's a lot of machine learning models. So after this, so if you have your machine learning models training your updated machine learning models based on the updated training sets, like you can remove this different history or different behavior in your history. I mean, that's one way to make sure you remove yourself from certain algorithms. I mean, that's at least from that perspective, I can see how Google is working on that. And in Luxio, actually, interestingly, people are also talking about, like, one of the reasons people are talking to us is really because they want to use us as a data abstraction layer to handle like different data in different places, and asking us, hey, whether you can add some filters or just help us to update the data, because we want to like, for example, update the training set or update the logs, and like you're using the term I was using in Google. So definitely that's we see this kind of like a demanding from market, and higher actually. Yeah, it's a lot of people are more and more people are talking to us, and they are looking for solutions. And for example, how to have this. Okay, all in all, I see like a big market opportunity for that. Put it that way. I think it's a really good direction, and I'm not following that closely. I don't know what's the state of the art, but I don't think there's like a very well established standard or a technology to help customers, users to do that.
Yeah, that's a good point too. And got a couple minutes left in our live show. I'll throw it over to Ryan. First, this right to be forgotten. Again, I think it is ambitious, but there is something to be said for, wanting certain pieces of your history to be removed. And then, you think about what goes into that. And so the point I was going to make too is, I recall from certain interpretations, at least of GDPR, that if someone says, I want you to remove me, you're supposed to retrain any algorithms that you had trained with their data. I'm not sure how strict they'll be about that, but that's a pretty substantial ask of the business, especially if they don't have a modern platform, right, Ryan? What do you think?
Yeah, I mean, GDPR is interesting. It's a UK thing right now, right? And people have taken and modeled their own versions of that, right? California has its version. Not all states have their version. I haven't looked. I've done a lot of stuff with GDPR on the data side, but not necessarily the model side. And it's absolutely true what you're saying, right? Is if you have to take people out of that model every time, it comes down to the timeline that it says, right? Because even in GDPR, you have a certain period of time to take that person out of the database. But if it were to change where you have to do it, retrain every time, I mean, you could imagine how painful that could be, especially, a lot of people use fairly small models, so your training time might only be an hour, 2 hours. But if you were involved in a really big data set,
right,
that's taking, a week to train, you could imagine the significant cost that it's going to be for a company to remove that data. Because, if you're running GPUs for a week, you're many thousands of dollars into training costs just to remove one person. So it would be interesting to see what the rules are there.
Yeah, and I think we are with all the work on observability. We've come a long, long way in the last few years in terms of being able to understand what does this cost. Companies like Snowflake, for example, I think they rolled out what they call resource groups, and they're doing that as a way to be able to get some understanding of how much it costs to run this algorithm, to run that algorithm, to store this data, to store that data. That kind of thing is very important for business people who have to try to figure out, have we gotten a return from investment on all this? Are we moving in the right direction? Are we moving in the wrong direction? So we're getting there, but it is a fast moving space, folks. Look all these guys up online. Very, very cool companies today. You have been listening to DM Radio.